Hello. So, welcome again to one of the Eurostruct live talks. And depending on where you are, I wish you a good morning, a good afternoon, or a good evening. It's a pleasure to be with you. And today we're gonna have with us Dr. Helmut Wenzel, that will give us our esteemed guest, that will give us a very interesting presentation about monitoring. And also with me on the moderation, we have Vikram Prakashi, which is a colleague that was also leading the WG5 of COST 1406. So from Ireland, and it will be very interesting and very promising today, this talk. I only have some information to all of you. The first one is to turn off your cam. And second, those who are in the Facebook or those who are seeing us in Zoom, if you want to put any questions during the talk, you need to make it either in Facebook or in the Zoom chat. In the Zoom chat, there is an account called Eurostruct Association account. So please send your question directly to this account, to Eurostruct Association account, and then myself and Vikram will place the question to our guest today. Finally, I would like to acknowledge our associate partners. I'd like to acknowledge University of Minho and ISIS for all the support concerning the platform and all these aspects. I'd like to acknowledge IAPSE and FIB for supporting on the dissemination level, and they are also associated to these talks. And I also like to acknowledge Boutique for the design and all the support with the web. So thank you once again for being with us. And now I'm going to ask Vikram to present our guest today. And let's start. Thank you.
Thanks, Jose. So it's a privilege to present Professor Helmut Wenzel today, who's the Managing Director of Wenzel Consulting Engineers as well. So I was very lucky to be working with him in Working Group 5 of Cost Action TU 1406 and later. And I think the recommendations and guidelines that were created in this working group wouldn't have been the same without Helmut's insights and inputs. And I think we can share some of this today in this talk. So Dr. Wenzel has been involved in bridge engineering and the construction and health monitoring since the beginning of his career. And there were major bridge projects which required the development of a lot of skills in design and construction technologies, as well as construction and asset management for successful completion. And in this capacity, Helmut serves as a technical advisor to many owners and operators of large infrastructure projects. So what you're going to hear today is something directly from what is implemented and what is relevant to the operators and end users. Also, Helmut developed the mathematical formulation of aging, which is now included in the new Eurocode on risk-based inspection framework. And this is EN 16991 2018. Also, if you wanted to read more about what Helmut's talking about, there's a relevant textbook. It's called Health Monitoring of Bridges. It's by John Wiley and Sons Limited, Chichester, England. If you wanted to note down the ISBN number, you can probably get a copy of it. It's ISBN 9780470031735. So I think at this point, the most important thing is to leave the platform for Helmut, and let's listen to what he has to say. Meanwhile, you can, as Jose said, keep on asking questions. So Helmut, it's all yours now.
Okay, thank you. Can you see me? Can you see the presentation?
Yes.
Okay.
Yes.
Okay, so welcome, ladies and gentlemen. I will give a very brief presentation on a large subject, which means that there might be some questions to be answered after this presentation. It's on risk-based monitoring and assessment of bridges. So give me some reasons why to use risk-based methodologies. Well, we have millions of bridges worldwide, and they are all different. Of course, there are some groups, and like in the US, you have sometimes very similar ones, but actually, they are all more or less prototypes. So there is no one-size-fits-all strategy. This means you cannot just take a textbook and do bridge assessment just following a cooking recipe. This will not work. So we have to be flexible. And it's all about availability and the quality of information we have. This is also in relation what Rade said in one of his talks before this one, that information is the basis for everything. We can do modeling, but if we have, let's say, halfway through information, our models will be wrong. And in my practice, working for a couple of thousand bridges so far, I always found that the availability is never perfect. So if we have 50% of the necessary data in good quality, that's quite a lot. So if you have clients that would like to, that working in this subject tells them that the data, this is the asset they have. Now for monitoring. Monitoring is mature. It is well developed and it shows performance. So a very, very good tool which we definitely need. So our models depend on parameters. And if we can measure these parameters, we can reduce the uncertainties. If we just estimate them, uncertainties will be much bigger. So this is one of the main purposes of applying monitoring systems, is to measure parameters and reduce the uncertainties. This will make the assessment more reliable and to the point. By to the point, I mean that very often we have certain aspects to look at. It is not only one risk or one type of performance or one type of, let's say, excessive loads to a structure. There are always several. And we have to go through them one by one. But if we have a very specific case, then the monitoring system can measure your specific parameters and then give you very good answers. But, well, actually you can monitor everything, but it is economically not feasible to monitor everything. Well, monitoring systems have costs, and if you put thousands of sensors, then first of all, you have to pay for the system, and second, you have to manage the system, which are running costs that no owner is normally willing to bear. So what we have to implement is flexible strategies which fit to categories of structures. By category of structures, I mean something like we have in Eurocode importance factors. If you have a signature bridge, which is a huge investment, it is justified to have more monitoring. If your bridge is a 5-meter span side bridge, then it might not be justified to use a lot of monitoring. And then why to do assessment risk-based? This is relatively new. It is more used in industries. You know, the production industries is running systems which are also large and where any failure has large consequences. So they need this information even more than we do. The reason is the lifetime of such units in the chemical industry, for example, it's normally 20 years, sometimes less. In our bridges, the big bridges have now 200 years or have 100 years. So this makes a big difference. So the time where nothing happens in the industry is shorter than the time on bridges. So in the end, the higher the risk, the more monitoring is justified. I will talk about this a little bit later again. So what does risk-based asset management mean? The objective of an asset manager is to get the best and most economic performance. So the asset manager has only a certain budget. He has to apply the budget in the best and most economic way. I think that's a very simple objective. But risk is actually what jeopardizes this objective. And ISO 31000 defines risk as the effect of uncertainties on the objectives. And ISO 31000 is a risk management framework, which also proposes monitoring in order to reduce these uncertainties. So there is a background that has been recognized already worldwide and documented in the code. So what we have to do is we have to adjust asset management to the actual performance. This is easy to say, but it is difficult to perform, and it has some very high impact on the economic performance. I will show you later a graph where it is easy to understand. And or we can go for condition. This is what many engineers prefer because the word condition is well known to them. Performance is not yet so popular in the industry. But condition is anyway a key indicator for performance. So you always have to look into condition because it will tell you when you have to do what in the end. And then on bridge management, our current practice, we have more or less a linear investment. Our guidelines or codes tell us that every second year we have to do a rough inspection and every 6 years a detailed inspection with an assessment. And this is independent of condition. This means we have more or less linear costs over time. A risk-based approach allows us to have flexible intervals depending on the performance. By flexible intervals, I mean that when a bridge is new, the risk of fundamental failures is low, so you can extend, let's say, your 2-year periods to 4 years. The problem here is mainly that these guidelines or codes, they are binding, and that the operators get responsible if they do not follow and something happens. So one of the things to do is to put some sentences on this in these guidelines. We in Austria, I think we are the only country that allows this, that has it written down that we can double the inspection intervals if we use monitoring for prediction. But this is coming in many other codes. Let me give you a look on a typical graph on that. On the horizontal axis, you have lifetime and you have performance on the vertical axis. The yellow line would be the performance of a structure over time. You can immediately see that the performance in the first half of the lifetime is more or less linear and then gets non-linear. This would be, for example, a steel pylon in salt water. You can apply the ISO 19902 for the inspection regime. And this would be the costs that you get. Here you can see the management costs. It is more or less a linear in intervals investment that these are the costs you have to bear if you follow this code directly. If you apply a risk-based approach, what you can do is you just follow this type of line and put your costs in the same type. So less investment in the beginning, more investment in the end. Where you land up is only a little more than half of the costs at the end of life. Well, this does not mean that you save half of the costs, because your monitoring effort you have to put in here has also a cost. But it at least allows you at the same cost to do a better performance. Now, one very detailed graph. I will not explain it in detail right now. If you want to look at it, you can go back to this video and look at it in more detail. We have developed this in a European project. Risk actually is the product of hazard, vulnerability, and impact. We have the hazards here with all these things of environment and so on. We have the vulnerability. This is how does your structure react to the hazards. And we have the impact side, with this society, operation, environment, and all these other factors. When you want to have, let's say, such a procedure established in bridge management, I have to tell you there is no code yet. I say yet because we are working on it for quite some time. And in the chemical industry, you could find examples where, let's say, the forms and where all these risk scenarios are very similar to what we have here. So please have a look if you want to look into that directly. This graph also contains the ISO or the Eurocode numbers, which could be applied here. Now, how to do that? What is risk-based bridge management? The proposed procedure, which I favor, is that we implement a suitable monitoring system. By suitable monitoring system, I mean that it must not be one with 1,000 sensors, but something that just tells me that there is a change. So just detection. You know, in science, we would like to have a detection, we would like to have an allocation, we would like to have a quantification and all these things. But for bridge management, in the first place, this is not necessary. It is just necessary to get an information that something is going wrong or is going outside of your performance model. The monitoring system will create trend cards. This means we look at the data time-wise and we analyze them. By doing that, we can reduce visual inspection by 50% through flexible intervals, as I have explained before. But you have to make sure that this does not bring you into a reliability situation you do not like. And with this information you create from the trend card, you can perform targeted mitigation. Mitigation is the cheaper, the earlier you find that there is a problem. And monitoring systems are 2 orders of magnitude more sensitive than, let's say, an inspection every 2 or 6 years. So this means in the end, when you also include the mitigation costs, you will be much better off in this management. So what will be the economic impact? So the total cost of bridge management will be the same. You know, monitoring costs money. People that manage and maintain the monitoring cost money. But you have to, or not you have to, you can reduce the costs for inspection and for other management activities. So you can keep it at the same level, but at much better performance. So through this early detection, as I said before. Now, how do we do it in practice? For monitoring, we start with a small economic system that indicates the changes on performance, or if you just call it condition, it's actually the same. It can be an index. Index does not have a very good reputation, but in the end, an index is understood by many people. And one of the problems we have is that those working on the bridge hands-on do not have all this education in, let's say, dynamic models or whatever it is, but they know what condition is. And in bridge management, we compute the risk. So this does not mean that we have only one risk. We have the risk of a storm. We have the risk of waves. We have the risk of traffic, of course. So we have to look into this separately. Then when we find some deviation from our normal predicted performance, we react on the changes. React on changes sometimes means, okay, I only know now that something is going not normal. Then I go out with a mobile system, or I make an intervention in the system in order to measure what is different. Based on this information, I can take a risk-based decision, which are normally much better decisions. The problem in this is then the communication from the engineer to the decision maker, because decision makers in many cases are not engineers, but rather lawyers or economists. And therefore, this risk communication is something that decides between good and bad application. So it is advisable to look into this subject. And then you can optimize the value of investment. Now, one of the promising approaches was this one, a basic concept of this change detection, this energy leakage. This is available from the IRIS project. This book is in the internet. You can download these things. It's from large experiments. We have done full-scale tests in laboratories and on site to find out that when a structure is damaged, then the energy which is in the fundamental frequencies here is traveling to higher frequencies with a degree of damage. We call it cascades, and the number is just the mode where it goes to. This is a very reliable indicator, but it is not, let's say, so easy when structures are very complex. This is an example from a real structure, a very big structure, where in the lower graph you see the structure is sound. It vibrates around 0.1 hertz, and after a damage has happened, you see how different this thing is. It's the same structure, it's the same sensor, so you see that the frequencies has dropped, and it is completely dispersing energy. This is something where the computer can detect by itself. You don't have to do a manual evaluation, because the difference between these two is so big that it is easy to detect automatically. So in this case, this thing has been applied already successfully. Now I give you two examples from Turkey. There are a lot of very big bridges built in Turkey, and very interesting approaches, record spans. This is the Osman Gazi Bridge across the Izmit Bay, 1,550 meters main span. And such structures cost $1 billion, so they deserve, let's say, special attention. So what the as-built structure has monitoring concepts here was a monitoring system built by the contractor with 420 channels and dominantly fiber optic sensors. Fiber optic sensors give you very good information on strain, but on a very, very limited place and in a very limited environment. The assets management by the operator, which is different. The contractor gets a contract and goes away when everything is finished. The operator has to deal with this thing. 89 channels are permanently used for warning. So this is for detection. This is only 20%, a little more than 20% of what we have here. And 331 channels are standby for rare events. You can play around with this channel. You can look at what happens, but well, in normal practical operation, there is no time and no personnel to do that. So the difference between what a contractor wants to do and what an operator needs sometimes creates some difficulties in using. And this trend card-based evaluation system, as I've shown before, is currently implemented by our Turkish colleagues. There are very good engineers there, and this will be one of the world-leading systems that might make a good example. The second big bridge in around Istanbul is the third Bosporus bridge in Turkey, also opened again. In this case, The bridge is now open for the road traffic, but there will be a railway built in between, in the middle. This is why you have this well, stay cables, and you have a suspension cable, which will finally support this railway structure. In this case, we had the chance to discuss with everybody what the monitoring system should do. And the monitoring system only has 124 channels. And this is good enough. The bridge is 1,408 meters span. This is almost the same same size. And it has dominantly dynamic sensors, acceleration and tilt. With this, we get enough information in order to make this assessment. And the SH management needs 112 channels for warning and only 12 on standby. So in this case, at the time of construction, everybody was on one table. On the other, there was nobody there from operation, unfortunately. Evaluation system is not yet ready. Here was also a good example because we were able to monitor the pylons. These are the largest pylon in the world, 320 meters. And in freestanding position, wind was a major issue. And this dynamic monitoring was able to monitor during this erection, and the system was directly integrated into the final monitoring system. So if you think about, let's say, from the beginning to the end, you can save money and use systems for several purposes. Now, at the end, I give you a list of relevant standards for bridge management. Again, I cannot talk about all of them, but you can go back to the video and get it. ISO 55000 is a framework of asset management. It mentions monitoring as a tool in order to find out what's happening. The second one is ISO 31000. It's a risk management framework. This is a direct basis. There are a lot of codes around that which give you details on how to do that. Then there is this Eurocode 16991. Vikram already mentioned it, on risk-based inspection. It's an industry code, but it contains the mathematical formulation of aging, which was developed based on bridges. So this code is very well usable, even so the title might lead you to the opinion that it is not good for bridges. It is good for bridges. We are currently working on ISO 21928, which is sustainability of construction works. Unfortunately, due to some intervention from the United States, environment is not so taken seriously too much anymore, and we are in delay. We wanted to finish it last year, but we are still working on it. This code will give you all the indicators, which are the so-called soft indicators on economy, environment, and society. This will round up our risk approach because when your 5 meter span footbridge falls down, it's different as if one of the big bridges collapses. So this makes an impact on the decision. In Germany, they're working on new guidelines and extension of DIN 1076. This is a very good example of a national code. But it requires a lot of input, which might not be enough funded in other countries. This one is our Austrian code, which I consider, I would say, the most advanced one, but it is only in German, and it is only for Austria, based on the practice we have here, because we are doing this for 25 years. You also have to consider the OSHA guidelines. This is for health and safety, and take your national safety and security guidelines into account, of course, and your individual management strategy. So this means this is your expertise. Now, second last slide is on how do we show this? I was talking about communication, risk communication. This is a good way to communicate it. If you say my risk case has, let's say, 120 parameters, and this is 1, 2, 3, 4, 5, and so on, your manager will not listen. If you group it into 6 groups, which we have here, this is, for example, safety. Safety includes ultimate limit states. This is what our Eurocode, for example, knows. Durability is durability limit state. Some experts use this in one go because there are some similarities. But the main difference is this one you can do almost completely at the design stage. And durability is very often influenced during the operation stage also. So to separate it means you address different parties, which is useful. Serviceability means operation limit state. This is your operation. This is an important thing, which is different from country to country and from the type of bridge, type of road, and so on. Economy is costs mainly. Environment are the sustainability factors. The new code, this ISO code, will have about 130 factors, and there's a very nice list. There will be an Excel file where you can say, okay, this is important for me, this is not important for me. And then you can compute you can call it index or whatever rating it is. And you do it for all these 6 points, and you will find out where is my critical point. For example, it might be serviceability, which is in many cases of the bridges. Let's say the clearance is not enough for all this kind, or the load is not enough. And if you connect these points to a hexagon, you have a measure for risk. So the smaller the area is here, the higher is the risk. This is something you can show to your decision makers and say, I have 10 cases, look at it, this is my critical case. And if you get then sensitive questions, you can say, okay, I have an, let's say an estimation of 4 here. This means that we have only 10 times to make a replacement of this structure. This is how it works. There's a lot of details in this here specifically, which I cannot explain here. We're currently working on a new publication on this, but this will take some time until we have it. So as a summary, so risk and performance-based approaches are preferable. They give you better results at the same costs, and if you apply them clever, you know we have a lot of bridges where we know that there is nothing wrong. And they are very well designed, and so this will give you a chance to even save money in operation. A must is a good IT concept. The IT concept, will, well, you will either do it or not. If the IT concept is bad, you will have so many problems with IT that you say, forget it. In future, we will use BIM definitely. We are not there yet in digital twins, but this will be helpful. I'm quite sure that this will be helpful in this asset management work. We should do the inspections flexible and targeted. Here again, digital twins are a very good tool, and there is a lot of progress made in this direction, and I'm quite sure that we will see some good examples here soon. Now the categories of structures. The first one, permanent monitoring should be applied to signature structures. This is no question, nobody doubts it, but many owners think, okay, I put the monitoring system there and my duty is done. This is not the case. You have to make sure that the operation also is able to use this monitoring system. The second group are the important structures. Let me say the first group might be 0.1% of our structures. The second group might be up to 5% of our structures. And we can use economic targeted monitoring on important structures. It is very often done, but not enough. There are many reasons for that. And the big number are the fleet of structures, 95%. On-demand monitoring is what we should do. Then in the end, establish a holistic risk management approach. If you can do that, you will do a good job. So that's it for the moment, and thank you for listening.
Thank you, Helmut. Again, it is a pleasure to have you here with us today. It was a fantastic presentation, and also it was very good to work with you and with Vikram, of course, in WG5, where we deal with some of these discussions and some of these points that you raised today very closely with Cost Action 1406. So I think we are right on the point. I would only like to inform, before placing the first question, I would like to inform people that they should put the questions either on the Facebook for those that are assisting us on Facebook, or you can send the question directly to the Eurostruct Association account in the Zoom, in the chat on the Zoom platform. In the chat, you can choose Eurostruct Association account and send the question, or your question, to this account. And myself and Vikram will be very happy to place the questions to Helmut. The last point is I will gonna ask everybody to turn off the camera because of a matter of Wi-Fi connection and to make the talk more stable. So thank you all for being here again. And now it's time for questions. And Helmut, I'm going to put you a first question. The first question I want to place to you is, it is true that monitoring is being used for a long time without reaching a breakthrough. Why is this happening, in your opinion?
Well, you know, I was part of it 40 years ago, and there were people before me, and all were scientists. And the scientists have a very different interest in the whole thing. You know, we want to know everything. And we do a lot of things that the practitioner will not need in the end. And if we ask too much, then people will say, okay, very nice, but not fit for me. So what we have to do is, and this transition from scientific monitoring to practical monitoring is a difficult one. And one of the reasons is, as all the cases are different, it is not so easy for a practitioner with not enough information to pick the right one. This is why there is no breakthrough. There is some better, well, it is going better now than it did 20 years ago, but there is still a lot to do to get to a breakthrough.
And in this sense, also, why do we have so many national bridge management practices, in your opinion?
Well, I think this is history. You know, the European Union is not as old. Bridges are older, so there is national practice which goes back 150 years ago. The first codes are in the 1890s on that, not codes, but let's say documents. And this has developed over a very long time. And the national authorities know about that. They are educated in this direction. And there is no wonder that there are so many. The disadvantage of having that is that well, this is very locally focused on local experience, and the use of all these new concepts and experience from all over Europe doesn't play a role. So we have to work on harmonizing it. If we harmonize it, we will have a total European performance which is much better than before.
Thank you. Now I'm going to ask Vikram to place the next question. Vikram, please go ahead.
So we just received an interesting question from one of the listeners that, let's say we wanted to replicate such monitoring in different countries or even upscale them. What would be some of your practical suggestions to be able to go about it or achieve it successfully?
Well, I think first of all, if you have a system you are looking at, you have to understand what the objectives have been and how the system works. And then you have to compare it to your local project and find out what the difference is. And I would say normally you can take over 90% of the risk-based strategy and adjust maybe 10% to your local conditions. You know, for example, is earthquakes. You know, there are different exposure to earthquakes in different countries. There's a lot of earthquake in Turkey, for example. There is not much earthquake in Germany. So this could be the difference, but you have experts to do that. So I don't consider it very difficult to transfer, let's say, the technology from one to the other. It's always good to talk to people and to talk to the operators on their experience.
So in the same line, if I might just ask, you just said like the word normal. So I mean, what are the normal expectations of bridge management managers, and why do you think such risk-based methods are so hard to communicate often in an industrial format?
Well, you know, the bridge managers have normally a very simple objective. You know, the bridge owner only wants to have the bridge open and working, not giving any help on, let's say, the whole background on safety and such things. And I said before that bridge owners very often are not engineers. So the bridge managers are then the poor guys that have to explain a thing which is complex and costly to somebody who is not yet educated for this task. So what they would like to have is, you know, in the beginning, a traffic light only. That we say, okay, we have a traffic light. Here is this element of the bridge. If the traffic light is green, everything is fine. If it's going yellow, have a look, and if it's red, there is danger. So this is what they really want. And I always try to educate them and say, well, it is not feasible that you have all the experts in your team. You will not be able to pay for all that, but you have to find out when to call an expert. And there are cases that are very complex, where we need very complex models. It goes in the direction also what Rade explained. We can do the models, but it's not everybody's darling. So when we give them this kind of indication in the beginning, and we support them then to communicate the results, then they will like it.
Helmut, we have here two more questions from the audience. One is with respect to the trend cards that you present. Since I imagine it's the time frequency domain analysis as a short time Fourier transform. And the question is, due to the dependency of frequency to temperature, if you think this method is a good indicator of damage.
Well, I think we have tested it in more than 10 full-scale damaging tests. So it works perfectly if you have the condition under control. The indicator that you need to take care about temperature is clear, but when you have a permanent monitoring system, to create a routine that makes this relation between temperature and structure, you know, you can directly exclude this from your trend card. You have seen the trend cards I've showed; they are almost horizontal because temperature is already excluded. These routines are standard. This can be applied, I would say, everywhere.
And the second question is about crowdsourcing. Is this something that is nowadays being very used since the use of accelerometers from smartphones and many other ways? Is it a valuable tool to invest on, or do you think it will create much burden in terms of data, in terms of big data?
Well, I think that big data in future will not be the big problem, but the problem is that every information or every data you get in, you have to put into information. And when you get information from crowdsourcing, you know, the quality of the information you can get out of that will be not high enough to make these predictions. For example, when I would not be able to make a trend card out of it. What I can do is, with applied this successfully in projects, let's say, to find out very quick where the epicenter of an earthquake was, for example. This is good. But to find out the condition of a structure, this will be very difficult. I do not say that it is useless. It is not useless. If we have, for example, traffic jams or an accident or such things on our structures, you know, we have damage from fire and such. This will be a good thing. But these are extraordinary situations which we are not looking into here. What we are looking into here is a long-term performance prediction, including a plan for investment to keep it functional for 200 years, for example, like the big bridges.
Okay, thank you, Vikram.
I'm getting some very interesting questions as well. So one question that I have especially is, in fact, I'll put those two questions to you as well. We have a question which says that we typically monitor a bridge under ambient conditions. However, in earthquake-prone countries especially, the high amplitude transient excitations are the most probable to create damage. So do you believe, Helmut, that the information we get from ambient vibrations, are they sufficiently reliable to assess the condition of a bridge in view that it's probably been struck by a large earthquake? So that's an interesting question. And the other question I had was,
maybe I can answer this one first, because it might.
Yes, no, that's fine. Yeah, that's an important one.
Yeah, you know, the sensors we use are normally dynamic sensors of very high quality. This might be also one statement that I would like to make. You know, use less sensors but use very good quality. This the information will be much better by that. So the systems we have, for example, in Turkey, they can manage an earthquake perfectly. And you know, we have on all the systems we have running there, we have a dozen of earthquakes already recorded. So this is this works, I would say, very well. Another thing is, you know, when you have a strong earthquake and you have damage, then you have these typical categories. The first one is that you know, the bridge should be still operable even if there is small damage. To make this automatic, I don't think that we are there yet. We will get the information. Many of our sensors will be out of range, and in a lot of the cases we had also the power will go off, for example. So let's not promise too much. When we have enough records during and also after the earthquake, we can tell you very quick it is safe to use the bridge. But to answer all the questions will not be possible.
That's right. And in fact, I got a couple of answers that I had myself, especially about high quality sensors or not. The other question I have is, you just mentioned that digital twins will be a part of the future. And how do you see the evolution of digital twins happening in the bridge monitoring sector?
Well, I think that bridges are a very good sector for digital twins. Specifically, the important or the signature bridges are very difficult to inspect. You know, how do you inspect such a suspension bridge? Or we have art bridges in the Alps. You know, you cannot look at it easily. So fly a drone and compare the result with an existing digital twin will give you a perfect first indicator on where to look at. Of course, when you see a crack in a let's say important concrete structure, then you have to go there and then make more assessment with different equipment. That's fine. But for the standard and quick immediate reaction when there is an incident, digital twins will be used everywhere. I'm quite sure on that.
Jose?
Thank you. Now is my turn. We have here a question which is more connected with about what is a typical range, percentage range that monitoring system could cost on the overall construction of a new major or feature bridge? Because this could have an impact on also on the decision of owners, no?
Yes, definitely yes. But the answer is there is no typical percentage because every bridge is different. So if you have a project of $1 billion, then nobody really looks whether the monitoring system costs 500,000 or 2 million. If you have a bridge which is 10 million, then a monitoring system might be in the range of 2% up to 3% of the investment costs. Then they will not take it, I guess. But this goes in the direction that I say, well, if you have a bridge of 10 million, do not place 50 sensors. Put a system with 10, 12 sensors, and this will be sufficient. But first of all, you have to look whether it is justified. If you have a very well designed, very well built bridge, it is completely new. Why should you put the system there? And frankly speaking.
But for owners to apply monitoring systems, actually, what are the main hurdles in your opinion?
Well, the main hurdles, well, I would say the main hurdles are with the operators, not so much the owners. The operators like it. They say, okay, I get more information, I can make better decisions. The owners say, okay, well, I have given you a nice bridge. So what else do you want? I don't have money for this kind of investment. So what we have to support the operators is with good arguments, and then in the end make an investment and benefit calculation and saying, okay, many of your bridges might be safe and good, but if you lose only one, let's say out of 100, then the costs will be so much, and the monitoring system costs only that much. If it's 0.5%, then it is still a deal. It is, I would say we have to look at it into a kind of insurance perspective.
Okay, thank you. Now, Vikram, please.
One interesting question that came up from was, what kind of damages have you been able to detect, and do you think that such monitoring will affect design considerations in future or safety factors for these bridges?
Well, in the proof of concept monitoring, for example, is a separate thing. In the big bridges, which have a monitoring system from the beginning, proof of concept is a very good thing. It shows you that your model you have made is so much wrong that you should do it again in many cases. Not so much on the very big bridges, but on our normal bridges, the differences between the model and the measurement were in average 28% was the resistance was higher than calculated. So the good news is this creates more safety. The bad news is you might have wasted money. So I think when you do it in a good way, you can reduce future, I wouldn't say safety factors, but you could improve future designs. Very often it is not the code itself, the restricting factor. Very often it is the design. So, the engineers nowadays are not educated in the way that it was previously to look at, first of all, how is the flow of forces and such things. Now you say, oh, okay, I have a computer and let the computer tell me what the forces and stresses and displacements are. So monitoring can tell you in the end, well, maybe your computer is right, but if you think a little bit about it, a better structure can be feasible.
So in those lines, I mean, another question I received was, so what is the interaction between the manager and the information that's coming out from the monitoring system? How do they interact and take decisions?
Well, when the manager is, for example, an economist or a lawyer, he would like to get, let's say, a percentage of remaining life. He would like to, this would be the sufficient information. If we tell, okay, design life was 120 years, bridge is now 80 years old, but your design life, you can expect is 60 years, then the manager will be happy because he can use the bridge 20 more years free of charge, more or less. So this is the information that the managers would like to receive. Don't tell them how beautiful your trend cards and how beautiful your spectra are, because he doesn't know what he sees on this. This is not to blame him, because he's a specialist in a different field. So make it simple and try to be convincing.
So, Helmut, one of the methods that you present in this presentation is risk-based. So we definitely agree that we will need to change to risk-based. But in your opinion, why are they so difficult to communicate? And is there enough education on risk-based methods and monitoring to be offered? Is this a lack?
Well, I think there's a clear reason. You know, engineers are deterministic. You know, the engineers know what the result is for sure. And when we go into risk-based procedures, we accept uncertainties. And so this means we have a result plus minus an upper and a lower band. And this is not appreciated by people who say, I know how it's going on. We have many old managers of our structures, and their intuition and their wisdom is important. And in a good monitoring system, you have an option for subjective input. This I appreciate this very much. You know, things cannot always be measured, but we have to take away the fear from these uncertainties, that they say, okay, if there is a 5% chance that I'm wrong, I don't feel comfortable. So this goes back to the education that at the time they have been on university, have been educated. Well, this risk-based or risk was not a subject, and everybody was trained to say, okay, if I follow the code, I'm safe. So this is an education job we have to do. We have to try to educate people, also people that are, let's say, away from university already for 20 years and are working in practice. We should show them how charming a risk-based decision is, and how much better I can achieve my objectives with that than with, let's say, a straightforward calculation that gives me in the end a safety factor.
Okay. Also, in this line of risk base, when doing maintenance optimization based on risk analysis for bridges, the establishment of a maximum acceptance criteria for the level of risk, having to account consequences and the probability of happening of this event, can be subjective. Or, in your opinion, there is any specific criteria that is already in the guidelines that we could use?
Well, in the end, there are subjectives. This is no question. In the new guidelines and in the new ISO code, you will find a much more, let's say, specific definition of what it is and how it could be measured. And well, we are dreaming about, let's say, a handbook on saying, okay, we have this and this parameter for societal impact, and then you, in your case, take this and this input, and you will be able to compute your parameter in terms of mean and of plus minus targets. But this is future work to be done. But it will, at least it will be helpful to give you all the headlines. I have to look into things like how far I am from the sea and such things, or what is the impact of sunshine on my structure. which we underestimate in our current codes.
Thank you. Vikram, please go ahead.
One question then naturally that comes, Helmut, is there then a lack of demonstrative benchmarks right now in terms of monitoring of bridges? And do you think they would be helpful in future? And if so, how should they be done?
Well, there is definitely a lack of benchmarks. There are a lot of good benchmarks that have been done already, but most of them under scientific objectives. So if you look to the literature, you will find hundreds of good monitoring cases, but not so much targeted on the practice of a usual operator. So, which does not mean that we do not have monitoring systems and these things applied in practice, but the operators do not have time or do not have the personnel to publish, and also the publication is not so easy because then they get a response, this is not scientific enough. The means of publication of, let's say, average cases is also difficult. So you know, what we have done in the past years was we have collected about 2,000 cases of bridge collapses. This is work that has to be done by somebody. We could do the same thing, well, collect 2,000 cases of good monitoring-based bridge management. But again, it's a question of costs. Who funds this and who organizes this? This is would be, let's say, a major thing to do.
In fact, in those lines, again, another query I had, and this is an ongoing conversation amongst many. So we traditionally have wired instrumentation, and right now, again, in terms of benchmark, in terms of the future, everywhere right now, wireless is a big thing. Do you prefer wired or wireless?
Well, there is no wireless system that can do the job for these large structures. And also the wireless systems are still limited in terms of quality they can deliver. You know, the good important sensors we use, they need more electric currencies than a wireless system can produce with the best methods we have right now. So if it's a permanent system, it has to be wired. And if we want to be very sensible, it has to be wired. We found recently that when you do, for example, the wiring during you install the SCADA system or the lighting and all these things, you know, you have the people there, you have the cable trays there, you have everything there. So wiring was not the key cost in these big projects we had in the past 10 years. Nothing against wireless. There are definitely applications for wireless, not so easy on bridges.
Helmut, we have here, I have here some questions from the audience. One is with respect to ultrasonic-based monitoring. How do you see this could be important in overall condition monitoring of full-scale bridges?
Well, ultrasonic is a very good application when you have already identified that you have a problem and you want to know the detail. So perfect. When you see that your structure is degrading, for example, a typical case are these bridges with a concrete deck. And concrete deck, you know, we have built two small concrete decks, 20 centimeter or 18 centimeter thickness, with not enough cover for the reinforcement and such things. Here, ultrasonic and for these radar things, you know, all this kind of non-destructive testing is perfect, but it's a second step. First of all, we have to find out whether it is justified to do it. When it's justified, bring it in.
And another question is also about the continuous monitoring over time of bridge displacements. Example, using satellite interferometry and so on. Do you see this could be also beneficial, and in what situations could we use it?
Well, displacement is one of the major input we need. You know, we have to understand how bridges and structures are displacing. We have tried a lot of satellite image things, but it was not successful enough to give us the precise answers we would like to see. For example, in terms of let's say settlement of piers, yes. But in terms of when we have all these Gerber structures, like the old collapse in Italy, for example, we need a millimeter information on how these beams and supports are working. So we use some optic sensors sometimes, or even the old wired sensor, because they live quite long and are reliable. But do not stop thinking about it or working on it.
Okay, thank you. Vikram, please.
Right. So I have only one or two other questions that have come in, which is good in some ways for Helmut as well. But one question we had here, it's quite relevant. So from all these monitoring things, you presented a hexagon scheme there, and a question came in that, okay, so we have wind, we have earthquake, we have other problems, but how do we decide what's the most important aspect on the hexagon scheme? And also from these monitoring, how do we decide on what kind of changes are required for the bridge? Is it directly from monitoring or not? I think it all comes back to how to use the hexagon system you just presented. So maybe a bit about that would be fantastic.
Yeah, I was very quick and too quick on that. This is for sure. You know, when you do a risk management, then you are not looking at one risk and one hexagon scheme. So this means you say, I have the risk of seismic activity, for example. This is one hexagon in the end, because seismic activity will also have other consequences on costs and on society and environment and so on. So you have to create all your risk scenarios. And it depends on the complexity of your structure and the environment, how many these are. But you cannot mix up all of them into one. And in the end, then you have maybe 10 or even 20 of them. And then you can say, okay, the smallest area, this is the highest risk. When you have only limited budget, where do I put the budget? This is for this kind of decision. So you have to always look at a very, very specific case. You have to make a definition. I always say that you need a clear objective. Then this means you have to know what you want in the beginning. And when we did monitoring 20 years ago, you know, we just put there what we would like, what we wanted, and the client did not have an idea what he gets and what he wants. Nowadays, I go there and tell them, okay, first of all, tell me what you want. Tell me what is your objective, and then we make a decision on what kind of instrument we put there. And the same thing is for this typical risk scenarios. We look at seismic separately, we look at wind separately, and we look at, let's say, impact on cables by a truck accident. We look on fire, and so we have a kind of standard cases, work through them, find out what the consequences are, and in the end we will know what where to put our protection measures first.
I think that exhausts the question bank that I received from all the listeners. So thanks to them, and I'll hand it over to Jose in case he's had any further.
I have here some questions. I'm going to place 3 questions to you, Helmut, and then I'm going to ask Vikram to put the last question. So the first question that I have from the audience, Helmut, is with respect to you spoke about the number of sensors in one SAGIM. Is there any future research directions in order to optimize this number for each type? What is your recommendation?
Well, there has been a couple of projects that were looking into optimal monitoring systems. But at the end, we have seen that the number of cases that might happen are so much that we will not find a rule where we say, okay, this is for this bridge, you need this and this sensor. I think the better way is, first of all, make a clear objective. What do you want to know? Then you look at the structure, and if you have enough engineering experience, you know where structures are sensitive, and then place your sensors. The most successful cases we have on ordinary bridges do not have more than 10 sensors. That's what you need when you have understood what your objective is. So I would say that it is not possible to give you a formula that you say you have so many square meters of bridge, this will be so many sensors, because particularly in terms of square meters, this doesn't say anything about the span. If you have 1,000 square meters with one span or 10 spans, makes a big difference. So, and you have all these kind of things that might vary. So, sorry, there is no one size fits all.
And also in this sense, in order to implement structural monitoring, we need to have some kind of standards. Is there any relevant standards for sensor systems and assessment? And what these standards cover, those that exist? Because I imagine it's not, as you said just now, it's not everything like repetitive everywhere.
Yeah. So for sensors, there are perfect standards. This is no question. You can, for almost every useful standard, you will find a standard. For systems, there are some standards out there. One of the most modern is this new standard for offshore structures in Germany. This is the first one where they were looking into sensor system and assessment in one go. So this means standards will develop on that. And then in terms of assessment, you will find several standards that give you a part of the story and an idea how to use it. The list I have presented before has most of these things. In there, you will find a lot of indication where to look at when you look at, for example, at the environmental assessment problem. You look into an ISO 14000 typical code. So you go there, and then you, by Googling, you will find the right one. But for final assessment, there is no standard yet. There is well, people would like to work on that, and the standard we are working on, you remember we have been there 4 years ago when we came in, but at that time they were already working for 8 years. So we are in year 13 now, and this will go on. And until a standard, when it is completed by the engineers, and then until it is approved and released, is another 2 years. So in the near future, we will not have a standard, but we have enough standards to convince people that apply it are safe. So if you say I go for ISO 55000, it tells me what to do in an asset. 31000, how to handle a risk management. With this, you can convince the owners.
Okay, the last question that I want to make to you is a curiosity, and with respect to the monitoring of the Turkish bridge program, because it's a question from the audience. They use fiber optic sensors, and in the second stage they use dynamic ones. And the question is, what is the difference? Okay, between the two types, but mostly why they change it from one type to another between the two stages of monitoring? Is there any reason?
Well, fiber optic sensors up to now are not really dynamic. So fiber optic sensors give us very good information on strain. It gives us good information also on temperature and related things, but not the dynamic signature. So what we do is, in the beginning, we use the dynamic sensors for identification And then if we add the fiber optics, for example, then we get the details. We will find the locations where the damage is, and we will find what the magnitude of damage is. So they are useful, but if we apply them in the beginning, they are most probably applied in the wrong position or not in the position where you need this information. Okay. I don't know if it sufficiently answers the question. It maybe came out a little bit wrong. On these bridges, it is not a change of the system. It is just that in the beginning, maybe the system was too big for the job to be done. And if we do the fiber optics at a time where we know that, let's say, there has been a damage to a hanger, then we have a very specific place where we need strain measurements. So on a bridge which is 4,000 meters long, and if you have even 400 fiber optic sensors, they are always in the wrong position.
Yeah, I agree. So Vikram, last question.
Absolutely. So I think it probably is appropriate if Helmut, if you could leave us with a final comment on something that almost always is asked. It's probably ridiculously direct. Why monitor bridges?
Well, bridges are, you know, the backbone of our economy. You know, without all these bridges, our economy would not work. So, and when we, you know, when you look at what the societal impact is of a bridge collapse, if you look to Genoa, for example, or we have cases also here in Austria where a small bridge collapsed, then the costs for reconstruction was 10% of the indirect costs which were on the local economy. So economy has to have an interest that our bridges are working.
So thank you, Vikram, to be here with us today.
And thanks, Helmut.
It was again a privilege to have Helmut with us, sharing his experience about monitoring of bridges, a very relevant topic nowadays. And I would also like to acknowledge all our associate partners, University of Minho, ISIS, FIB, IABSE, and Boutique, and to all that you are here. It was, I believe, all of you got a very good income from this Eurostruck talk. Before closing the talk, I would like to give you some information about the next events. So, and about a survey. Eurostruck is running a survey which actually is now on Facebook, and you can fill it. It's a survey concerning the operation of civil infrastructures during the COVID-19 period. So for those that are assisting, we will be happy that you could fulfill this survey. And also I have information from IABSE mentioning that the symposium in Wrocław, which was supposed to take place on end of May, was rescheduled to the 7th and 9th of October. And the IABSE task group meetings and welcome reception for the participants will be on the 6th of October. The early bird registration is still open, and you can do the registration until the 15th of June, so this month. With respect to New Delhi, next year, you know that the deadline was end of May, but if you still wish to submit an abstract, the platform is open, and please use this opportunity to submit and to visit India. From FIB, I also have the information that the FIB in Shanghai was rescheduled to 22 to 24 of November, and the abstract submission and the early bird registration were postponed, and they are still open. With respect to Eurostruck, So next week on the 18th of June at 2 p.m. Central European Summer Time, we are going to have the next talk with Professor Paulo Lourenço. Then the training course, which was supposed to be in Ireland, it was decided to be completely online. It will be the first Eurostruct training course fully online, and will be held from the 2nd to the 4th of September. So if you go to the website or in Facebook, you have the registration. You can register on the training course and also learn about these risk-based procedures that we discussed today for evaluating the performance of our bridge stock. Finally, the next year we have in 2021 the Eurostruct conference in Padua in Italy, and will be held from the 29th to the 31st of August with a welcome reception of the 3rd to 29, and then with the conference running on the 30 and 31. So I hope you can attend and visit the pleasant city of Padua, and the abstract submission will be open very soon. So it was very nice to be with you today. I wish you a good morning, good afternoon, or a good evening, depending on where you are. And thank you again to my fellow, to Vikram and to Helmut, to be with us today. And see you next week for another Eurostruct live talk. See you. Thank you very much.
See you. Thank you.
Thank you. See you.
Bye.
It's an absolute pleasure.